Okay, this video is going to cover what we did in week 7, day 1. I apologize for the voice. My voice is bad, but I have to do this. So the first thing we did is we went through, we practiced these problems. So go ahead and do these on your own. Pause the video and come back and check the answers. So here we go. This is after we went through 2-7. Today we practiced these. So 7 plus 3. Remember, it's use the calculator, drop the decimal if they're ints. If one of them, at least one of the operands, is a double, then you use the calculator and keep the decimal. So the 7 plus 3 is 10, and so there's no decimal, so just keep it. This 7.0 plus 3 has to be a double. So in the calculator, you would get 10.0, and so you would keep the decimal. 17 divided by 8 is, you do the calculator first. Which will give you 2.125, and so we did the calculator, but this is an int divided by an int, so we drop the decimal, so the answer is 2. And here 17 divided by 8.0 is the same thing in the calculator, but this time, since you have a double as one of the operands, you keep it, so it's 2.125. 6 divided by 11 has to be an int, but 6 divided by 11 is 0.5454, etc., etc. Oh, I missed. Okay, there we go. You got to be an int though. So we did the calculator. Now we drop it. Drop the decimal. So this is 0. The Java will see that as being 0. The next one is looking for the remainder. 5 goes into 27 5 times. It has a remainder of 2. And 14 divided by 7 is 2 with 0 as a remainder. So this is all this is looking for, is the remainder. All right, let me go on to the next one. All right, now we're going to look at the compiler and calculations. And this is going to be the next step up. So what's going to happen is as you're writing programs, you're going to have calculations, and we're showing that down here. We have calculations and that are going to be stored into memory locations. And so, well, how does the compiler deal with these? And so in here, the compiler is going to, when it sees a problem like this, is going to do the calculation on the right first. It's going to do the calculation. So don't even look, when you do these calculations, don't even look at this. You just look at 3 times 4 like what we just did in the previous slide. That's an int times an int. And so that tells us that, that this is a 12. So 12 is is an int, and now it's going to, and the next thing it's going to do is the compiler, after it does the calculation, it's going to try to store the result in the storage location. It's going to try to store the result in the storage location. So it's going to take this 12 and it's going to try to store it in num1, which is an int. Now, here's what happens with this. This is very important. Is you gotta the compiler, the result has to obey the data type or display an error message. It's going to do one of the two. So it's taking an int and it's storing it in an int, which is fine. So it obeys the data type, and so it stores a 12 in that memory location. That's not a problem. The next line here, if you notice, the 3 times 4.0, well, that has to be a double. because an int times a double is a double, so it's 12.0. Now, it's going to try, the next thing it does is it tries to store the result in the storage location. So it takes this double and tries to store it in here, but it's an int. Now, this is the important thing that you need to add to your notes. And I should have done this earlier, is this. Well, you know, it's actually on there already. It's important that you write down that doubles can store ints as doubles, but ints are too small to store doubles. So what happens is, and I think what I'll do is this. So doubles can store ints as doubles. Ints are too small for doubles. So here's, we're going to have to look at this. I forgot to type this up. Okay, so what happens is we have primitive data type. First of all, you should write down the data types refer to the capacity, the storage capacity of a memory location. So it refers to the size, so to speak. And so we have what we call primitive data types. The one that has the lowest capacity of storage is called a byte. And we don't have time to get into what all that is, but then the next thing that we have is what's called a short. So that's going to be a numeric data. That's going to be like an integer, only it's a short one. And that has more storage capacity than the byte. The next thing is int, which we're familiar with, has more storage capacity than short and byte. Then there's a long, which also stores integers, but they're longer integers. It can store more, it can store larger numeric data than an int, a short, and a byte. Then they come to the float, the floating point data types, which are decimals. And so the first one is a float, which can store, which is a decimal, and it stores more than a long, int, short, and byte. And then the largest one is the double, which has more decimals in it, can store longer decimals, and it is has the bigger storage capacity of all of these. Now, we're talking about size. And so if you take something that's the largest and try to take and store it in something that's smaller, it's not going to fit. So if you were to try to take a large container and try to store it in a small container, it won't fit. If you try to take a small container, and you can store it in a larger container. And so we demonstrate that with cups, a small cup and a big cup. So on this, so on this one, the 12.0, it's too large. It's a double, and doubles are larger than ints, and so it can't fit in there. And so what you get is is an error message, and the error message is going to say incompatible types. The double does not fit inside of an int, so you're going to get an error message. And then this one is a regular, is just an int, but an int, this int is going to be trying to be stored in this double, and int is smaller than a double, so it will fit. So there's no error message, and so it will store the double, though it will store it as 12.0 because it's got to obey the data type. So an int stores in a double as a double. It's got to obey the data type. All right, let's go on to the next thing. All right, now your homework 210, I think it this is going to be just like you are going to do in 210. So this is important that you follow this carefully. You are going to be asked to set up and track your storage locations. So you should have this stuff written down on your notes. And these, of course, are all results of these declarations with initializations. This all is going to be done in the computer memory. And so you should be writing these down and tracking them. So the first problem is A is assigned C divided by A. Now this is not A equals C divided by A. It's A is going to be assigned, and we're going to store the result of C divided by A inside A. Now C, we're going to apply what we learned on the previous slide. C is 31, and this is what some of you need to do, is write the return values up here. So 31 divided by 4 means that you have to have an int. The other thing I would suggest strongly for some of you is to write down the result of that calculation. And of course, that's going to be 4 into 31 goes 7 times, because an int divided by an int is an int. Now, the next step is to try to store it in this memory location. Now, this is an int. We're storing an int, so no problem. So in your memory location, you change it to a 7, okay, because a variable varies. It can change, and it only stores one variable. And so if the value of A is used in a program, it's going to use the most recent value of that variable or that memory location. So A is no longer 4, it is 7. Now we go to the next one, and we go P is assigned the result of C divided by B. Well, C is 31 and B is 6. And the result of that is 5, because an int divided by an int has to be an int. Now it's going to take that 5 and try to store it in P. Well, P is a double. And so it's going to store it all right, but it has to obey the data type as we talked about in the previous slide. So it's going to store it as 5.0. Okay, so let's go on to the next one. Now, in this one, P is not 3.0. You got to check your memory locations. It's a 5.0. It's the most recent value. So it's 5.0 times B, which is 6. Now, if you just do that calculation, like we've learned how to do, a double times an int has to be a double. So it's going to become 30.0. Okay, now we're going to try to store this double inside of this memory location. Well, C is an int. So it's trying to store a double in an int, which we said in the previous slide. A double is too large. So therefore, this is what you need to do on your homework tonight, is you need to write the word error. So you actually write this on your paper, just like I'm showing, and it will tell you to do this on the notes, but this is what I mean. You write error. And then put line comment symbols in front of the line of code. So that way, the compiler then, this shows the compiler ignoring this line of code because it's an error. It can't do anything with it. And therefore, there are no changes in the computer memory here because it's an error message. So then you go on to the next one. Okay, this is P, which is going to be assigned M divided by B. So M is 14.7, and it's divided by B, which is 6. And so that has to be a double, because a double divided by an int is a double. So 14.7 divided by 6 is equal to 2.45. So now it's going to take that 2.45 and it's going to try to store it in this memory location, which is a double. So this becomes 2.45. No problem. Now let's go one more, I hope. No, actually, we'll just stop here. So this is the idea for tonight's homework 210. And so make sure you follow this as you do that on the handout that you should have received in class.